illustrate some of the reasons we want to put EOF into EVM. So about 2 years, in the beginning, the legend has it that the two of the early core developers were responsible for writing EVM, and they did it over the weekend. And it wasn't perfect, but it was really good, and it got almost everything right. I think the only thing that they changed before it went public was they added one of the C++ client developers who's on Team Epsilon now, asked them to add the jump test operation in there for jumps to signal that this is a correct place to land. And they needed that for JIT compilation for the LLVM. And that's an important thing to keep in mind, is that JIT compilation is going to be a running theme. It's going to come up with the ZKVMs. So they added that feature, and it was good enough. It wasn't the thing with the most problems. It was stuff like syncing nodes and keeping consensus together. So they moved on from that. So it worked, but there was still a few things that needed to be added early on into the EVM. Call code didn't work like they thought it would, so they replaced it with delegate call. There were some performance issues with some of the opcodes, so they increased the prices on some of them appropriately. There was bit shifting math wasn't exactly what they expected it to be, so they added some bit shifting code. And there were some developer experience requests to put in things like the revert opcode, so you could signal to the system that when a call failed in an unexpected way, that you could pass data back within the stack and outside of the stack. And also some precompiles for some advanced cryptography were added, because that's just too inefficient for the EVM to execute. So one of the first big proposals to do more than just add one or two small things to the EVM was EIP 615. That's a really low EIP number. And it was proposing, the top line in the motivation says the design of the EVM makes near linear time compilation to machine code difficult. The jump test analysis and a few other things that were in there. A malicious person could write a piece of EVM software that would take a really long time to compile and provide another form of attack to the EVM. So that's why it wasn't really, EVM just-in-time compilation really hasn't gone too far. It's because of issues like that. And so this was designed to address some of those issues. The biggest things they added was they provided a static jump instead of a relative jump, and they also added subroutines. And the last three items, if you look at them and squint really hard, it looks a lot like what we have designed in EOF. They have a begin data section to say anything after this opcode is data. They have an object header that says this is EVM code. And they have code validation rules that say that everything between the beginning of the header and the beginning of the data has to be valid executable code. And if you stand back and squint your eyes, that's some of the key features of EOF. So way back in 2017, a lot of the needs for EOF were recognized. So the obvious question is, well, why wasn't this done at that point in time? We had all the stuff in place to get it done. The reason is Ethereum 2.0, aka Serenity, was announced about not too long after this EIP was announced. And it was proposing some major changes to Ethereum itself. Among those was switching to proof of stake, and also introducing data sharding, and as part of step 2, introducing eWASM as an alternate form of execution. And then finally, the phase 3, step 4, was a bunch of other improvements. And you'll notice the further down we go down the list, the more and more it changed from the original vision. Proof of stake shipped pretty much as envisioned in Serenity. The data sharding became the roll-up centric roadmap, and the eWASM was eventually abandoned for reasons I'll get to in the next slide. But that last point, they didn't have the idea of ossification built in yet, and there's a big push to ossify the protocol at this point. So why was eWASM abandoned? Why they put a lot of effort into it? Why didn't it ship? There were a number of reasons, and one of them was just the complexity around it. We were going to have to keep the EVM around and eWASM around, and there was proposals and plans to try and get the shifting between the two versions to cross-compile EVM and eWASM. But also eWASM does not natively support the gas into it. You would have to weave the gas into it and have validation rules relating to the gas. And there are also issues related to the 256-bit math. And that really is what caused a lot of the performance problems. The Epsilon team went through a summary of the performance of their eWASM prototype in Osaka, and they came public that it wasn't as performant as they was hoping it was going to be. There were some things that could be done to fix it, but that it wasn't going to hit its main goal, which was to be faster than interpreted EVM. It was kind of a gut punch to the Epsilon team, but they did the right thing, and they brought the data out and showed what was going on with it. So looking at all these things with the EVM, we should probably look and ask, before we ask why EOF, we should ask, why not EOF? Couldn't we just do all these changes without doing a big change to the EVM and just do these things piecemeal? So this next section will talk about, answer that question of why not. Why couldn't we just, just introduce immediate jumps with immediate codes? Why couldn't we just do subroutines? Why couldn't we just enforce code data separation and validate the code? Why do we have to do this all at once in this big giant change? And the problem is, all of these features are deeply intertwined. You really need to do them all at once because the value comes in all of them together at the same time, not in them individually. And doing them individually actually creates new problems. So the first thing we'll talk about is relative jumps. And relative jumps, as I mentioned before, you needed to put the jump target into the code using something called an immediate argument. And the push opcode is an example of things that have the immediate argument. So if we added a new one, let's say we're going to pretend we're going to do this. E0 is going to be the new rjump instruction, and we have a 2-byte signed field that's going to tell relative jumps. And you'll see from this that we actually, on average, save a byte if the contract is over 256 bytes long. The problem comes with existing code that may have this opcode in place for a number of reasons. So here's an example up here I have of a code that may exist that has a couple of push instructions. One of those push instructions has the 5B instruction that is the jump dest target. And then we go into some extra data that has a bunch of invalid opcodes. The E0 opcode is not allocated, so the EVM doesn't care. The 5B exists after the E0, FF, C9, 2A. So if we introduce a new E0 opcode that takes 2 immediate bytes without doing anything to this other pre-deployed contract, we've changed the meaning of it. That jump dest is no longer valid. So code that used to run and execute and hit that jump dest is now going to fail, and you've done nothing to change that contract except change the rules of the VM. And this is the sort of change in Ethereum that we frown upon and we try our best not to do. We try not to break what has already been out there. So to add immediate opcodes would break things that exist already. And here's another piece of opcode that shows why we really need to get rid of relative jumps. This is a nightmare code that I learned about a few weeks ago. You could literally take, that someone actually wanted to make sure that they could still kind of do an EOF, is you can take some info from the call data, trim it off, and jump to a specific spot in your code based on that call data. They were using it as a vector jump instruction, but this is just mind-blowing that people were actually, I thought this was something that you would do as a malicious attack, not that something you find utility in. And there are people that like to do things like this in their code. So this is why we need to provide, stronger guardrails around some of this. So one approach that was tried was to just version the contracts. EIP 1702 was briefly in Berlin before it was taken out. And so we would say, great, you were going to introduce E0 with immediate data, great. All new contracts deployed after Berlin and later will have this rule, and all contracts defined below won't have the E0 opcode. And we'll just have these versions, and every fork will add a new version. This was ultimately rejected because every fork was going to create a new version of EVM rules that would grow and grow and grow. Sometimes they apply and sometimes they don't. Rather than having just 2 sets of rules, you would have an infinitely growing set of rules, which was going to be problematic complexity-wise. So that was ultimately taken back out of Berlin after it was initially brought into it. Another thing that was taken out after it was put in was simple subroutines. And this also underscored another problem that we had during the design process of some of these opcodes, is we didn't always directly interact with the compiler developers. So this was implemented by all of the clients. It was ready to go. Tests were written. And then a couple of weeks before we were scheduling test nets, someone pointed out that Solidity said, we're not going to use this opcode. So if Solidity's not going to use it, there was quite a discussion on all core devs about why do we even have this in there. And ultimately the decision was to take it out. I think it was in Istanbul, and this was taken out of Istanbul. But we did get one change in before the merge that is very important and foundational for EOF. Any contract that begins with EF cannot be deployed anymore. So we can guarantee you that if the code starts with the EF byte, that certain rules will be able to be applied within it. So as part of the Berlin hard fork, that was passed in, and no, the London one of them before the merge. There's so many of them, I keep forgetting. But it was enforced so that you could not implement code that would use this. We could preserve space for our validated contract containers. There was some emojis that were deployed to kind of cause problems. But where this brings us up to is this brings us up to the merge. And the merge is kind of an important milestone in a lot of these EVM changes, because for a while, in all core devs, to ensure that we were focusing on getting proof of stake pushed through on all the clients, any and all consideration of EVM changes was put on pause until after the merge. So during this time, Epsilon team went and they were cooking, and they thought about all the things that they learned from eWASM, and they came up with this plan for EOF, and they presented it at Devcon Bogota. And that brings us to talking about little EOF and big EOF. They had originally designed it in multiple pieces and to present it to all the core devs to say, how much do we want to do? Do we want to do a little bit of it? Do we want to do a lot? Do we want to bring in these modules and do it all together? So it was kind of a cafeteria approach. How much do we want to break as part of this? And so they were called little EOF and big EOF. Little EOF started with the EVM object format v1. This was the container format, the foundation. Code starts EF0001. You have a header section, you have code, you have data, it's separated. One of the neat things about this that's better than EIP 615 is you know the size of the container. So you know if you get a truncated EOF container, you know you don't have all the code, and you can just reject it, so you're not accidentally missing code. That was something that 615 didn't have, the ability to say the code ends here, the data ends here, this is the whole container. The next feature that was added was code validation. So for that code section, if the opcode was not allocated, it couldn't exist. And if you had a code requiring immediate data, all of the data for that immediate had to be present in the code or it would be rejected. An important thing about the EOF validation container format is if it doesn't parse, the entire transaction and the code is rejected, the contract cannot be put on the chain. So similarly with code validation, if code validation fails, the contract is rejected and can't be placed on the chain. So after code validation, they started to add new opcodes, because as part of code validation, they also went ahead and banned opcodes. They banned the old dynamic jumps and replaced them with relative jumps. And again, in the relative jumps, they did one more improvement above 615, in that they made these relative jumps, not just static jumps. 615 had static jumps and would list the PC you would jump to, but these are relative, giving a 2-byte signed integer to say how many operands before or after do you move to, which is nice for compilers because they can lift and shift all of the code that they need. And then for big EOF, we added functions, which is the answer to subroutines. It allows us to basically provide all the same functionality with subroutines, just with multiple code sections. And this is something that account abstraction is looking to use to provide a secondary entry point in for a lot of their functionality. So it's a bit superior to subroutines in that regard. And finally, stack validation. This is the most complex piece of code and specification that is in it, and I think it's the most important piece of code that is in big EOF. What this allows us to do is if you can evaluate your code and you can pass all the stack validation rules, then at runtime for all of your operands, you can just ignore stack validation. You know that you will have enough operands on the stack, and you know there will be room on the stack, and you can remove all the code that you were doing to check to say, is there enough room in the stack? Do I have enough operands? Do I have too few operands? The downside is it makes you do good things with code, but any modern compiler is going to spit out code that is completely compatible with stack validation. One minor caveat for an optimization, we added ranges for validations, and this was useful and requested by Solidity so they could have one revert section rather than having to have a revert section for each stack height. So you can come into that revert section with a range of opcodes and then exit the entire contract. So this is a tweet that I came across a few weeks ago, and this was like something really exciting to me. Someone had a residency at Sync Labs, and they went through and they implemented EOF in a ZK context with the same contracts that you do with legacy. And they got some amazing numbers. Just by implementing these features, you can get rid of all the stack checks and a lot of the other validation checks because you can presume it's valid. And it reduced and it improved performance by 3 times. So that much time was spent just validating stack heights. And that's me. I mean, when you ship a 10% improvement, that's when I get excited and I start shipping stuff. This is like 300%. This is better than I hoped for. So it's already providing real value in ZK contexts. And AOTs, they get benefit, but not nearly as much as ZK's got. This is amazing. So we were ready to ship this in Shanghai, except we had one minor issue with the Solidity constructor. But Vitalik, about a month before our interrupt, dropped a bomb in that he wanted to get rid of code introspection, which was another thing that was bothering him for ZKs. The ability to take memory into code and code into memory caused all sorts of problems with ZKs and made things really difficult for them. So we wanted to remove all the code introspection. So the interrupt was decided that we were going to take it completely out of Shanghai and add new features to remove code introspection. And also everyone said, well, while we're breaking things, let's break everything we want to break, do it one time, do it once and for all, because we'll never have to do this again, right? And hopefully, we'll be able to just get everything that we want broken and get it fixed and do it right. So that brings us to Mega EOF, where we break everything that needed to be broken, we do it once, and we try and reduce the number of times we're going to have to update the base major version of EOF. And the first thing we started with is contract creation, which is a code introspection. Code introspection mostly impacts the create opcodes and also the create transaction. So the solution that EOF came up with was that they would put the subcontracts in as sub-objects in the container that would be validated at contract creation time. So when you do a create or a create2 type operation, you take that already validated code, you deploy it on the blockchain, validation is done, and it never has to hit the memory. So you say, I want to deploy that, and there's some other things going in there. You're allowed to put extra data into that and append data onto the existing data and let it grow. So you can do your constructor arguments and do things like Uniswap's pair contracts wants to have the token numbers burnt into the code. So this allows you to do that. The next thing was the contract creation transaction. This is a slight modification of existing contract creation in that if there's any data after the EOF container, it's passed in as input data. So you can provide constructor parameters in addition to creating it. And through this, you can create objects you can create contracts without having to copy any of it to system memory. Another request that came from that we needed to do to ensure that we have, I forgot which slide I'm on, but one thing we need to add to make sure that we had code introspection fixed was we need to be able to get at the data section before the ext codes copied everything in the container. So we needed to add new opcodes that would allow you to access just the data section. It's just your data section right now, so that we get a little bit of code privacy benefits there, so you can return only the data you want. So we need to add new opcodes for that. And then after we're done with code introspection, the next thing was to get rid of gas introspection. Gas introspecting and restricting the amount of gas that you send on to your next layer of contract has created some problems with breaking contracts when we increase and change the gas schedule. So if we don't allow you to mess with the gas like that, then we're safe changing the gas schedule and doing whatever changes are necessary. And the solution there is just to get new call opcodes. We introduced 3 new call opcodes that don't have gas as part of their input parameters. And also, as a nice side effect, we can address address-based expansion because all the opcodes in the EVM trim all addresses above 160 bytes. So these call opcodes do not, so it's safe for address-based expansion. And that only leaves balance as the only open opcode, and that's one opcode to fix to get full address-based expansion safety if we decide we want to do that. The compiler teams ask for swap and dupe instructions, and the Viper team specifically asked for an exchange instruction, which is kind of like a super swap. Rather than swapping it at position 1 to something deep in the stack, you take something up to 16 items deep in the operand stack, and you swap it with something else, another 16 or so spaces deeper in the operand stack. So you can switch stuff around. You can save 2 instructions by doing 1 exchange instruction. It's pretty neat. Now, this wasn't everything that we wanted to put in EOF. In order to reduce it and make it more testable and reduce the attack surfaces and the risk surfaces, there are about 4 features that we removed from it. TX create is something that we might see return. It's a way to do contract creations through a transaction. Variable length quantities, if we want to increase the contract sizes above 64K, we're probably going to need to do some changes to the contracts to make sure we can access the areas. Don't necessarily need it, though. There are some issues with EISP, with the NFT ERCs, and with some ERCs that deal with tokens like ERC20 style that require detecting if a contract is an EOA or not, and they do that via code size. So we're looking in ways to address that. We'll probably address that in Osaka. I'm optimistic we'll get that in there. And finally, external data copy. We're going to investigate that and figure out if it's needed. So here's a diagram that Dragon put together that explains the similarities and differences between EOF and EVM unvalidated contracts. They're more similar than they are different. EOF just has a container format and different validation rules and a few different opcodes than the EVM does. And when you go into executing it, it uses the same execution logic for EVM and EOF. I know I've been in all the major clients. It uses the same loop, so it's pretty awesome. And I'll just finish on this slide. Solidity said that by orders of magnitude, the EOF design is what they want for the future of the EVM. Right? Thanks.
Thank you, thank you. We have time for a few questions. And again, you can vote to get the question that you want pushed to the top. And so we're going to start with, what is the motivation for not allowing EOF contracts to delegate to legacy code?
One of the opcodes we banned was self-destruct, and self-destruct deletes the code, and it deletes all of the storage, and it moves value over. We wanted to remove the concept of code disappearing. So the reason why we had to ban delegate code is you could delegate call into a legacy contract that had a self-destruct operation, and you could bring the effect of a self-destruct into an EVM opcode. And also, delegate call on alt VMs has been an attack vector for some of their precompiles, so it just solves two birds with one stone.
Thank you. All right, is EOF the new VIA IR?
It's kind of an inside baseball question. I don't know, not really. I mean, some people don't like VIA IR, but what it is going to solve, the stack too deep problem, you're going to be able to use more than 16 variables. So it's better than the new VIA IR.
Since EOF will have performance benefit, are there plans to decrease gas costs when using EOF?
I think more likely we would increase gas cost of legacy if we did that. But the performance benefits from the gas cost of EOF are you just have fewer bytecodes, you have fewer operations. So you'll see we've measured that between like 3 and 5% just by using EOF in the same contracts. So you'll get savings just by using it without having to change the schedule.
Amazing. How far is Solidity support for EOF?
So one of the engineers from the Epsilon team has a prototype that compiles to the existing format of EOF v1, and that's where we got our numbers for the 3 to 5% gas savings. So Solidity is not going to ship it until EOF ships, so it's going to stay in a branch until it actually is in the test nets.
Amazing. Do you expect Solidity to require a breaking change between 0.8x and 0.9 to add EOF support?
It wouldn't surprise me. That's a decision for Solidity to make, but that is probably the best way to signal that you're going to be using EOF semantics. Other things, they might require new pragmas, but I think that's something for Solidity to answer.
What was the reason why Solidity didn't use subroutines in that prior iteration? And are those concerns mitigated in EOF?
I think it actually cost a few extra bytes the way it was implemented. It wasn't saving enough bytes. It was actually costing a few more bytes. And with 24K contract size limits, every byte's precious. So I think that was their main motivation for rejecting it.
Why does EOF not suffer from the complexity of versioning?
It will, 5 to 10 years down the road. What we're doing right now is what's taking so long is we're taking every possible breaking change so we don't have to do that major breaking change in the future. So what we're left with is we're left with a code base where we can add the new features that we have in a compatible way. So when we add this new feature, every version of every possible EOF contract that existed before would still be compatible in a hypothetical EOF v11 or v12. So it's fully backwards compatible by design.
Is EOF more ZK friendly?
Yes, in two ways. Getting rid of the code introspection means they don't have to worry about bytecode coming off of the memory and creating a new contract. You can know before you write your ZK proof what contracts you're going to have to worry about. And the relative jumps and getting rid of jump test analysis and being more certain about where your jumps are going to land is huge.
And I think we have time for one, maybe two more. Will subroutines and EOF make code size analysis easier?
It can. It depends on what the compilers do with it. And if people are trying to obfuscate their code, it's going to provide new creative ways to obfuscate. So it goes both ways.
This is a good one. When can we get rid of the EVM entirely?
The EVM or the legacy EVM? So the problem with the legacy EVM is there's some old contracts that we still need to support. Getting rid of sunsetting the legacy is something that we have in mind. We don't know the answer to it. We need to be able to say we can't do it because of reasons X, Y, Z, or we need to have a plan to do it, and that's something we're going to be looking to in the next couple of years.
Amazing. And the last one is a little bit more of a comment than a question, so I don't know if there's a place you can direct people to read the data section of other contracts.
Right. So the reason why we didn't want to directly do that is we want to give contracts the option of saying, no one can read my data. If you want to allow someone to read your data, you expose a function that you then copy your data and send it back. But we're going to figure out over the next couple months if that's going to be sufficient, if there's going to cause problems. So there is a way out. The question is it the right design choice? So I'd encourage people who care about this to call into our EVM implementer calls and let us know why you feel it's important.
Thank you so much.